Hello and welcome to the walking talking topic Transformations question 7 with me, Mr. Barton. Right, it's the big four again. We're going to have to do all four types of transformation and they're a little bit trickier this time, but there's bags of marks available. Start with part A. Enlarge the shape shown on the grid by a scale factor of 2 using A as a centre of enlargement. So there's A. So let's do our usual. Let's work out how far we've got to go from our centre to our point and make sure we go twice as far. Look at this sneaky thing they've chucked in here though. That top of that little house is 1.5 spaces away. So instead I'm going to go twice as far, which is 1, 2, 3 spaces away. So I reckon that's my new top of my house. What about this point here? That is 1, 2 away from the centre of enlargement, 2 down. So instead I'm going to go 4 down. 1, 2, 3, 4 down. What about this bottom bit of my house? That's 1, 2, 3 away. So instead I'm going to go 6 away. 1, 2, 3, 4, 5, 6. Let's take this corner. 1, 2, 3 to 3 down and 1, 2, 3 to the right. So instead I'm going to go 6 down. 1, 2, 3, 4, 5, 6. And I'm going to go 6 to the right. 1, 2, 3, 4, 5, 6. Now at this point you might be tempted to just draw in the rest of your house, but I wouldn't risk it myself. I'd keep working out the points. So let's try this one. 1, 2 down and 1, 2, 3 to the right. So I'm going to go 4 down, 1, 2, 3, 4, and I'm going to go 6 to the right. 1, 2, 3, 4, 5, 6. And I reckon that's what my house is going to look like. Let's join it up, but then let's do a very mechanism just to see. Join it up there, join that up there, join that up there. And in fact, seeing as we're on a roll, we might as well check it 2 different ways. Firstly is the lengths. Let's check every length is twice as long as it should be. So let's take this base. This height is 1 high. Here it's 2 high. Things are looking good. Second check is that if you join up with a point or with a line or your ruler, the original point and the new point, they should always go exactly through your centre of enlargement, which is a really nice checking mechanism. 3 marks for that. Very generous, but we've got to make sure we get them. Now, what about this? Reflect the triangle in the line y equals x. Once again, if you don't know what that looks like, you're not going to get this question right. That is a line where every y coordinate is equal to the x coordinate. So if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. Yes, it's everybody's favourite diagonal line, y equals x. So let's join our line up. It'd help if I could see straight. There we go. There's y equals x. For a laugh, I'm just going to label it y equals x just to impress people. And now, to do a reflection in a diagonal line is a little trickier than a horizontal, coming from my point to my line and then bouncing the opposite way. Well, not the opposite way, but kind of at 90 degrees. So let's take this point here. It goes 1, 2 to the right, so I'm bouncing it 1, 2 down, and it's going there. This point here goes 1, 2, 3, 4, 5, 6, 7, 8 to the right, bounces 1, 2, 3, 4, 5, 6, 7, 8 down. This point here, 1, 2, 3, 4, 5 to the right, bounces 1, 2, 3, 4, 5. Now if you're thinking, flipping heck, I'm sick of this bounce, right or not? But I reckon there's my answer. And what you can also do is just check diagonally whether they look like they're the same distance away. So that's kind of 1 diagonal square, 2 diagonal squares and a half. And that's 1 diagonal square, 2 diagonal squares and a half. That is 1 diagonal square. That's 1 diagonal square. So that can be your kind of checking mechanism as well. But that's 2 marks for doing that fairly tricky reflection there. What's next on the list? Ooh, bit of translation. They're working us hard with this one. This time we've got the translation 5 minus 3. Now you've got to know what that vector means. The top tells you whether you go right or left. If it's positive, you go right. So that's 5 to the right. Bottom tells you whether you go up or down. If it's positive, you go up. If it's negative, you go down. So that's negative, so we're going 3 down. Every point's got to go 5 to the right and 3 down. So here we go. Let's take this point. 1, 2, 3, 4, 5 to the right. 1, 2, 3 down. Done. This point, 1, 2, 3, 4, 5 to the right, and 3 down. 1, 2 down. Done. This point here, 1, 2, 3, 4, 5 to the right, 1, 2, 3 down. Again, personally, I wouldn't gamble all the points on their own. Join them up and use that mistake anywhere. Danger is if you do 1 point and then try and jump them all up. If you've made a mistake at 1 point, you mistake on every point. And finally, rotate the triangle 90 degrees anti-clockwise. Finally, a bit of variety, anti-clockwise. through the point 2, 1. So first, let's get our 2, 1 marked on. That's 2 along the x, 1 along the y. There it is. And we're going to have to go 90 degrees anti-clockwise. Right, I'm running out on my tracing paper. Remember, use my tip here. If you're dodging quarter rotations, line up your tracing paper so it goes along one of the sides of the grid like that, and it makes it easier for you to tell when you've done a quarter of the way around. So let's draw me triangle on here. There it goes there. Pop me pen on my centre of rotation, and I've got to go 90 degrees, and I'm going the opposite way around this time. Turn it until my tracing paper is no longer vertical but horizontal, and I end up with it like that there. I then keep an eye on my coordinates, so I think that's 2 minus 2 and 2 minus 5. Let's get them on there. 2 minus 2 and 2 minus 5, and my memory's awful, so I've forgotten where those points were then. So let's put me thing back on there. Turn it around, no harm in doing it twice. Pop it on there, and there it goes there. What's that at? -1, -5. -1, -5. Join them up. Bit of a point. Bit of a point. And bit of a point. And hopefully your completed triangle should look like that, and you get a nice 2 marks. That is a quick run through of all the different transformations.